Hi gang. A quick review of multiplying by multiples of 10, hundreds, or thousand. The first thing we need to recognize is what a multiple of 10 is. Now, if I were to count by tens, would I eventually land on this number if I were to count by tens? If you said yes, you would be correct. Now, if this number is a multiple of 10, and it is, you can count 10, 20, 30, and we would land on this number, then all you have to do to multiply is to ignore the 0 for a moment and do 316 times 3. Now, we know that 3 times 6 is 18. Drop the 8, carry the 1. 3 times 1 is 1, plus the 1 is 4. Nothing to carry. 3 times 3 is 9. Now, because, as we determined a while ago, this is a multiple of 10, we take this 0 right here, and we just slap it on the end of our answer. So therefore, 316 times 30 gives us 9,480. That makes sense? Let's try another one. Let's try 426 times 40. Now the first thing you ask yourself is, are either of these a multiple of 10? If you were to count by tens, would you eventually land on this number? The answer is yes, you would land on 40. 10, 20, 30, 40. So since that's the case, ignore the 0 for a minute and do 426 times 4. 4 times 6 is 24. Drop the 4, carry the 2. 4 times 2 is 8, plus 2 is 10. Drop the 0, carry the 1. 4 times 4 is 16, plus 1 is 17. Now, because this is a multiple of 10, we take this 0 that's over here, and we just put it on to the end of our answer, like so. So 426 times 40 is 17,040. But now let me ask you this. We have another here. We have 563 times 51. Let me ask you this. Is 51 a multiple of 10? If you were to count by tens, would you eventually land on the number 51? You would not, would you? So therefore, we cannot use our multiples of tens, hundreds, and thousands to solve this problem. In order to solve this problem, you would need to use either lattice, what we call the big 0, the model area, or area model, or the, what am I missing? Distributive. Distributive. So please be aware of when you should use the multiples of 10, hundreds, and thousands, or when you should use one of our other methods that we've talked about in class. Let's try another one. Let's try 3,224 times 20. Ask yourself, is this a multiple of 10? If I were to count by tens, would I eventually land on this? The answer is yes. Therefore, just ignore the 0 for a minute. Multiply everything by 2. This is real easy. 2 times 4 is 8. 2 times 2 is 4. 2 times 2 is 4 again. 2 times 3 is 6. Because this is a multiple of 0, you take that 0 and pop it on behind my answer. So it'll be 64480, or 64,480. Now I have some questions for you. I want you to look at the problems I have written here. Now, on this problem right here, 312 times 46. Can you use the shortcut for the 0? Or do you need to use a method like lattice or big zero or one of those? You have to ask yourself, is this a multiple of 4? Is this a multiple of 10? If I counted by 10, would I eventually land on 46? No? Okay. If I won't, then I need to use a method, either the lattice or big zero or area model or distributive. Alright, what about this next one? Is this a multiple of 10? If I counted by 10s, would I eventually land on 60? So yes. Well, since it is a multiple of 60, I can use that 0 shortcut. So yes. Alright, let's try another one. Alright, what about these? You ask yourself, is this a multiple of 10? If I count by 10s, would I eventually land on 23? Could I use a shortcut of 0? Do I need to use a method? If I count by 10s, I will never land on 23. So this is not a multiple of 10, so therefore I cannot use a shortcut, and I need to use a method of lattice or big zero or model area or distributive property. Alright, and one more over here. With this problem, without me saying much of anything, can I use a shortcut of a 0? Or do I have to use a method? What is your answer? Did you notice that this is a multiple of 10? That if you counted by 10s, you would eventually land on 30? So therefore, I don't have to use a method, and I can use a shortcut. Hope this helps.